Happy morning to all. Happy morning. Okay, the yesterday video I gave some equation how to write the overall reactions. Somebody asked a few doubts about that. I cleared that. I sent a video again to that particular person. And today also, if you have any doubt, please call me. I will help you. And today our learning objectives to learn about the preparation of hydrochloric acid. What is our learning objectives? To learn about the preparation of hydrochloric acid. All of you know that the formula for hydrochloric acid is HCl. Here the reaction between sodium chloride and sulfuric acid. The reaction between sodium chloride. What is the formula of sodium chloride? NaCl. NaCl is the formula of sodium chloride. Am I right? And sulfuric acid, the king of an acid, mineral acid, that is H2SO4. The reaction between sodium chloride and sulfuric acid, we get hydrochloric acid, and also sodium hydrogen sulfate is also obtained. And also one more reaction. The reaction between sodium chloride and also sodium hydrogen sulfate. The reaction between the sodium chloride and also sodium hydrogen sulfate, we get hydrochloric acid and also sodium sulfate. These are the two preparations. In the small class, we may learn about that, the experimental detail about the hydrochloric acid, preparation of hydrochloric acid. In our syllabus, in our plus 2 grade, in our state board syllabus, we are expecting only the equation, how to write the equation for the preparation of hydrochloric acid. How to write the equation. That means all of you must learn this question. That is the reaction between sodium chloride, the formula is NaCl, and sulfuric acid, H2SO4, gives hydrochloric acid, that is HCl, and sodium hydrogen sulfate. One more reaction also. Sodium hydrogen sulfate on react with the sodium chloride, we get hydrochloric acid and also sodium sulfate. Here, what are the physical properties of hydrochloric acid and what are the chemical properties of hydrochloric acid? The first physical properties of hydrochloric acid, it is a colorless, it have no color. Hydrochloric acid is a colorless and also pungent smelling gas. One of the pungent smell, one of the smell coming, hydrochloric acid. And also it is a gas. Hydrochloric acid is colorless, it is a pungent smelling gas. Okay. And also it is easily liquefied to a colorless liquid. It is easily liquefied to a colorless liquid. And also the boiling point of hydrochloric acid is 189 Kelvin. What is the boiling point of hydrochloric acid? 189 Kelvin. And also what is the melting point of hydrochloric acid is 159 Kelvin. What is the melting point of hydrochloric acid? 159 Kelvin. It is easily soluble in water. Hydrochloric acid can be easily soluble to water to form a hydronium ion. Okay? Can you say about the 2 points, maybe 2 points or 3 points about the properties? What are the physical properties of hydrochloric acid? What are the physical properties? Any 3 points? Can you remember any 3 points? One is it is a colorless. We have no color. It is a colorless. Pungent smelling gas. Okay, it's the first point. Second point, it is easily liquefied to a colorless liquid. It is easily liquefied to a colorless liquid. And what is about this boiling point? 189 Kelvin. What is the boiling point? 189 Kelvin. And also the melting point? 159 Kelvin. It is easily soluble in water. Okay, and also having one of the properties is about the aqua regia. Otherwise called, we have seen that royal water. It means we are taking 3 parts of concentrated nitric acid and 1 parts of hydrochloric acid. Okay, 3 parts of concentrated nitric acid and 1 parts of concentrated hydrochloric acid are mixed together to form an aqua regia. Okay, otherwise called royal water. What is the uses? What are the uses for this aqua regia means? to dissolve the gold, dissolving gold and also platinum, etc. Okay, let us we can be write how to write the equation for the preparation of hydrochloric acid. Please all of you take the note. This is a very important question. How to write? We are expecting the equation. Only chemistry means fully you should be write the equation. Okay, please all of you take the note and we can be written practice. Okay, please all of you take the note. The laboratory preparation of hydrochloric acid. The laboratory preparation of hydrochloric acid. Okay. Previously I told you that how to write the equation. Okay, equation. First we are taking sodium chloride. Sodium chloride. What is the formula for sodium chloride? NaCl. Sodium chloride. This sodium chloride on reaction with sulfuric acid. Sulfuric acid formula H2SO4. Am I right? Sodium chloride on reaction with sulfuric acid, we get one of the hydrogen combines with the chlorine. One of the hydrogen here combines with the chlorine. What is the product? Hydrochloric acid, that is HCl. Am I right? HCl plus what is the remaining product? Sodium, that is Na. Here one more hydrogen again. Sodium hydrogen sulfate. NaHSO4. Sodium hydrogen sulfate. Here. Next one. From sodium hydrogen sulfate, formula is NaHSO4. Okay. The sodium hydrogen sulfate on reacts with sodium chloride. So what's the product? Here hydrogen combines with this hydrogen combines with the chlorine. Am I right? This hydrogen, one of the hydrogen combines with chlorine to form HCl. HCl plus what's the remaining product? 2 Na is there, so Na2SO4. Na2SO4. What is Na2SO4? Sodium sulfate. Sodium sulfate. Clear? For the examination point of view, you should be write at least one equation. Those who are interested, you can be write the two equations. Okay. We are expecting compulsory one equation. That's okay. Next about the preparation. Properties of hydrochloric acid. Already I told you that the properties. What are the properties? Hydrogen chloride is a colorless, am I right? Pungent smelling gas. Okay. It is easily liquefied to color liquid and is about the boiling point. What's the boiling point? 189 Kelvin, and also the melting point is 159 Kelvin. And also one more important point, it is soluble in water. Hydrochloric acid. Hydrochloric acid reacts with the water. Okay, can you say what's the product? This hydrogen combines with this water molecules. This hydrogen combines the water molecule, we get H3O plus Cl minus ion. That is hydronium ion. Okay, what is the name of this compound? Hydronium ion. How the plus is came? Do you know that one? That is here this hydrochloric acid can be split up into two ions. Am I right? That is HCl split up into, that is divided into H plus and Cl minus ion. Clear? So this H plus on combines with water, we get H3O plus. Okay, this on combines the water to get H3O plus, and here have Cl minus ion. Okay, chloride ion. Am I right? Next about what are the chemical properties of hydrochloric acid? What are the chemical properties? First of all, hydrochloric acid reacts with the metal. Hydrochloric acid reacts with the metal. We are taking zinc and magnesium metal. Which are the metal we are taking? Zinc and magnesium metal. Okay. The symbol of zinc is Zn. This Zn on reaction with the hydrochloric acid, okay, we get this zinc on combines with Cl molecule. Zinc on combines with the Cl molecule, we get ZnCl2. That is zinc chloride salt. Okay, that is what? Zinc chloride salt plus the evolution of hydrogen gas. Okay, hydrogen gas. Okay, okay, gas is mentioned here arrow mark in the upward direction. And here having 2 chlorine, 2 hydrogen, so make it 2 here. Now the equation is balanced. Can you write this equation? It's an important question. How hydrogen chloride react with the zinc metal? Those who have the textbook, please write the question answer there. How zinc reacts with the hydrochloric acid, and also how magnesium reacts with the hydrochloric acid. Magnesium, symbol of magnesium is Mg. Mg, magnesium on reacts with the hydrochloric acid. Can you say which product is obtained? This magnesium combines with the Cl. Magnesium combines with Cl. What is the product? MgCl2. Okay, MgCl2 plus here the evolution of hydrogen gas. Okay, here having 2 chlorine, 2 hydrogen, so make it 2 here. Next about this hydrochloric acid reaction with some of the salt that we can be taken as sodium carbonate, calcium carbonate, and sodium bicarbonate or sodium hydrogen carbonate. Okay, these are the examples. First one, how sodium carbonate reacts with hydrochloric acid. What is the formula for sodium carbonate? Na2CO3. Am I right? Na2CO3. This is the formula for sodium carbonate. This sodium carbonate on reacts with hydrochloric acid. So can you say which are the products are obtained? What are the possibility? First one is the sodium combines with Cl. Okay, what is the first possibility? Sodium combines with Cl. So what is the product? Sodium chloride. The formula is NaCl. NaCl. Here I have 2 sodium, so make it 2 sodium. Okay, sodium chloride. Okay, next about hydrogen combines with oxygen. One of the oxygen. Hydrogen combines with one of the oxygen to form. It's called what? Water. Plus here the carbonate is converted into carbon dioxide. Okay, so how much chlorine is there? 2 chlorine, so make it 2 hydrogen. Okay, now the equation is balanced. Alright, equation is balanced. Next about how calcium carbonate. Calcium carbonate. What is the formula for calcium carbonate? CaCO3. Calcium carbonate. This calcium carbonate on reacts with hydrochloric acid. Can you say which product is obtained? One of the calcium combines with the Cl. One of the calcium combines with the Cl to form calcium chloride, that is CaCl2. Calcium chloride and the hydrogen combines with oxygen to form water. Plus carbonate is converted into carbon dioxide. Can you write? You should be balanced the equation. Here, how much chlorine is there? 2 chlorine. Okay, 2 chlorine, and also hydrogen is also balanced. Next, water, carbon dioxide is also balanced. Okay, next about what happens? Sodium bicarbonate. Sodium bicarbonate formula NaCO3. Sodium bicarbonate reacts with hydrochloric acid. Sodium bicarbonate formula what? NaCO3. Sodium bicarbonate on reacts with hydrochloric acid. Can you say which are the possibility? This sodium combines with Cl to form NaCl. Okay. Hydrogen combines oxygen to form water. And also carbon dioxide. Carbon dioxide. Okay. Now the equation is balanced or not? Already balanced. As per the textbook, it is not balanced. Okay, right? Okay. This is balanced only. Sodium there. Chlorine also there. Hydrogen also there. And carbon dioxide is also there. Okay. Now the equation is balanced. Otherwise, make it 2 here. As per the textbook, make it 2 here. Okay, 2 to balance. Next about 2 is here. And also 2, make it 2 here. Okay, and also here 2, 2. Carbonate, so balance. Okay, clear. As per the textbook, it is also, but also previous also it is a balanced solution. Okay, next about, I told you that the reaction between sodium sulfide to hydrochloric acid. Sodium sulfide. What is the formula for sodium sulfide? Na2SO3. Na2. That is the sodium sulfide. Sodium sulfate. Sodium sulfate means Na2SO4. Am I right? Na2SO4. This is sodium sulfide. Na2SO3 on reaction with hydrochloric acid. So what are the possibilities? What are the possibilities? Sodium combines with chlorine. Sodium combines with chlorine. Sodium combines with chlorine. What's the product? NaCl. And hydrogen combines with oxygen. Hydrogen combines with oxygen. What's the product? H2O. Am I right? Plus here sulfur trioxide is converted into sulfur dioxide. Sulfur trioxide is converted into sulfur dioxide. SO2. SO2. Am I right? So how can we balance the equation? 2 sodium is there, so make it 2 sodium. How much chlorine is there? 2 chlorine, make it 2 here. And also water is also balanced, and everyone is balanced. Am I right? Next about one of the very important question. Repeating what is the question? What is meant by aqua regia? Aqua regia. That is, I already told you that. What is an aqua regia? Can you say what is aqua regia? Aqua regia. Okay, aqua regia. Other is called royal water. Here we are taking three parts of concentrated HNO3. What is HNO3? Nitric acid. Okay, this is also a mineral acid. Plus 1 part of concentrated HCl. Okay, here 3 parts of concentrated nitric acid and 1 part of concentrated hydrochloric acid are mixed together. Okay, we get aqua regia. So we get what? Aqua regia. Here, what is the use of aqua regia? That means we are dissolving gold. For what purpose we are used? Here means by dissolving gold, platinum, etc. Okay, these are the uses of aqua regia. It's a very important question. What is aqua regia? What is aqua regia? The 3 parts of concentrated nitric acid and 1 part of concentrated hydrochloric acid. They are mixed together, we get aqua regia. What's the use of aqua regia? Means for dissolving gold and also platinum, etc. Okay, here how to write the equation for the gold react with the nitric acid and also with hydrochloric acid. Gold reacts with aqua regia. Okay, how the gold reacts with aqua regia and also how the platinum also reacts with aqua regia. Okay, that's also important equation. Please also take return practice 1 or 2 times. You should be right again and again. You write the equation. Okay. Here we are taking gold. What is the symbol of gold? AU. Am I right? AU. This AU on reacts with HNO3. That is, I told you that 3 parts of nitric acid. Am I right? Here the nitric acid can be written as H plus NO3, nitric acid. Okay, nitric acid. And also you should be take hydrochloric acid. Already hydrogen is having, so you don't need to write the hydrogen. Here only write Cl minus ion. Okay, Cl minus ion. So gold plus nitric acid. Nitric acid having the ions are H plus and NO3 minus ions. Okay, NO3 minus ions. And also hydrochloric acid. We are already having hydrogen. So we should be write chlorine. Okay, chlorine. Okay, chlorine ions. So what's the product? Here, this gold combines with the Cl minus ion. This gold combines with the Cl minus ion. We get AuCl4 minus. Okay, one of the complex we are saying. Okay, AuCl4 minus ions. And also here we get, so nitrogen combines with oxygen, we get NO molecules. Okay, NO molecules. And also hydrogen combines with the oxygen to form water. Which are the products we obtained? Here, gold combines with Cl. We get AuCl4 minus ion. And also nitrogen combines with oxygen, we get NO molecules. And also hydrogen combines with oxygen to form water molecules. How can you balance the equation? That means AuCl4, here having 4. Okay, 4 ions. And also we should be right. Oxygen, we have 3 oxygen. They are having 2 oxygen. Okay, so you should be making here 2. Okay, 2 plus 1, 3. So how much hydrogen is there? 2 2s are 4. So make it 4 here. I think that the equation is balanced. Am I right? Here, how much hydrogen is there? 4. Here also make it 4. And nitrogen also 1. Oxygen we have 3. 2 plus 1, 3. Now the equation is balanced. So, what is the name of this compound? Okay, what is the name of this compound? That means, here, how much chlorine is there? How much chlorine? 4 chlorine. So, we should be saying, if 1 chlorine means we are saying mono, am I right? 2 chlorine means di. 3 means tri, am I right? And 4 means tetra. Okay, what's the name? Tetrachloro, am I right? Tetrachloroarate ion. What's the name of this compound? Tetrachloroarate. Okay, AuRAT, arate. Here having one of the minus charge, so you should be saying ion. Tetrachloroarate ion. Okay, gold you should be saying arate. For example, AuCl3, we are saying auric chloride like that. Alright, okay, for this complex name we have in the 6th lesson, I think that coordination compound like that lesson is having about, we can learn that lesson, okay, about how to name the complex, okay, that we can discuss later, okay. Here the name of the compound, how can you say the name of the compound? 4 chlorine atom is there, so we are saying tetrachloro. For the gold you should be say arate. So we are plus or minus carrying, so it should be right ion. Okay. So name of the compound is tetrachloroarate. Have you any doubt about regarding for writing this equation? If you have any doubt, please call me. Okay. Next one, like that, I told you about that. What is the use of aqua regia? What's the use of aqua regia? To dissolving gold. Am I right? To dissolving gold, and also one more I told you that platinum. Okay. Which one is platinum? What is the symbol of platinum? Pt. Okay, Pt is the symbol of platinum. This platinum on reacts with nitric acid can be written as H plus NO3 minus ion, nitric acid. Okay, H plus and NO3 minus ion, and also this should be right Cl minus ion. Already that means 3 parts of nitric acid and 1 parts of hydrochloric acid. 3 parts of nitric acid and 1 parts of hydrochloric acid. So we are taking already hydrogen is taken as a common. Okay, for each acid, that means nitric acid and hydrochloric acid, hydrogen is also taken as a common. Okay, so hydrogen, nitrate, and also Cl minus ion. Okay, we get what's the product? Pt Cl is 6 2 minus ion. Okay, what's the name of this? What is the formula? Pt Cl6 2 minus, and also nitrogen combines with oxygen. Nitrogen combines with oxygen NO plus also hydrogen combines with oxygen to form water. The same as per this equation. Okay, same as per the equation. Here PtCl6, PtCl6 plus NO plus water. These are the products are obtained. How can you balance the equation? Here having 6 chlorine is there. So first, is it not possible to balance out of 2? So here we should be making here 3. Here 3 into 6 how much? 3 into 6 is how much? That is 18 chloride. Okay? So PT also making 3. Now PT balance. That is platinum balance. Next about chlorine and chlorine also balance. Next about NO here. For easy balance to make it 4 here. For easy way to balance here, make it 4 way. How much nitrogen is there? Nitrogen 4. Am I right? So make it 4 here. Next about oxygen. How much oxygen is there? 4 into 3 is equal to how much? 12 oxygen is there. 12 oxygen is there. So already 4 over. Here 4 3s are 12. 12 we are minusing 4. How much remaining? Remaining means 8. Am I right? 8 oxygen. So oxygen is balanced. What about hydrogen? Hydrogen means that is 8 into 2 is equal to 60. So 60 hydrogen. Have it out? Shall I do once more? Okay, once more I am writing. First of all, platinum, we have symbol, also you know that one, platinum, PT, am I right? PT, on reacts with nitric gas, that is HNO3, we are taking H plus NO3 minus, and also 1 parts of hydrochloric acid. That's we are taking chloride ion, Cl minus M. So what are the products obtained? PtCl6, 2 minus ions. Am I right? PtCl6, 2 minus ion plus the same product, nitrogen combines the oxygen to form NO plus hydrogen combines the oxygen to form H2O. So how can you balance the equation? It is not possible to balancing by 2. It is not possible. So we are taking 3 multiplied by 3 here. So 3 into 6 is equal to, that is 1, 6, 12, that is 18 chloride ion. Am I right? So how much platinum is there? 3 platinum. So here we get 3 platinum. Okay. Then also, if we are multiplying 2 means it is oxygen is not balanced. 3 also, oxygen is not balanced. We are multiplied by 3 also. This best way, the suitable number is 4. If we are multiplied by 4 into 3 is equal to, we get 12 oxygen atom. So we have 4 nitrogen and also we can make here 4 only. So 4 is over. Next about the remaining, out of 12, if you are cancelling 4 means the remaining is 8. Am I right? So 8 oxygen. So oxygen also balanced. Then the remaining one is hydrogen. 8 into 2 is equal to 16. So make it here 16. Now the equation is balanced. How can you say the name of this compound? How can you express the name of this compound? Okay, here how much chlorine is there? 1 means already I told you that. 1 is mono. 2 means di. 3 means tri. 4 means tetra. 5 means penta. 6 means hexa. Okay. How much chlorine is there? Hexachloro. Right? Hexachloro platinate ion. Okay. Platinate ion. Otherwise, platinate 2 minus ion. Hexachloro platinate ion. Okay. Here, why here platinate 88. Here also having R8. What's the reason is here having the minus. Negative symbol having the, you should be right 8 platinate ion. The name of the compound is hexachloro, CHLO, hexachloro, okay, CHLO, hexachloro platinate ion. These are the area we can be discussed later for the 6th lesson. Okay, that is coordination compound. That we can be learn all the rules. What are the rules for saying the complex name? Okay, so these are the two equations. Okay, and also what are the uses of hydrochloric acid? What are the uses? So what are the uses of hydrochloric acid? What are the uses of hydrochloric acid? It is used for the manufacture of chlorine, ammonia, ammonium chloride, glucose, starch, horns, etc. Okay, these are the uses. What are the uses? First one, manufacture of chlorine. Next one, ammonium chloride, glucose, and from corn, starch, etc. These are the uses of hydrochloric acid. The second one is, it is used for the manufacture of glue from bone and also the purification of bone black. What's the meaning of bone black? That is, we are saying that bone charcoal. These are the uses. What's the first one used? For the manufacture of chlorine, ammonium chloride, etc. And also the manufacture of glue. Okay, these are the two important uses of ammonium chloride. Next about trends in physical and chemical properties of hydrogen halide. Okay, trends in physical and chemical properties of hydrogen halide. That means how can we prepare hydrogen halide? How can we prepare hydrogen halide? Already we know that halide, halogen, we are saying halogen. Here fluorine, chlorine, bromine and iodine are called as halogen. That means we are combination of hydrogen and fluorine. That is the combination of hydrogen and chlorine, the combination of hydrogen and bromine, and the combination of hydrogen and iodine. These are the combination for hydrogen halide. We are saying that this combination, we are saying that hydrogen halide. Okay, so the first one is hydrogen chloride, that's hydrochloric acid. It is prepared by the direct combination. What's the meaning of direct combination? Simply we have the reaction between hydrogen and chlorine. Hydrogen and chlorine. Here hydrogen and chlorine combines to form hydrogen chloride. This is the first one. The second one is hydrogen reacts with fluorine. This is one of the violent reaction. One of the violent reaction is easily formed hydrogen fluoride. The third one is hydrogen with bromine and hydrogen with iodine are the reactions or reversible reaction. What's the meaning of reversible? We are saying forward reaction, backward reaction, reversible reaction and irreversible reaction. What is the meaning of reversible? That is, again, the hydrogen combines with bromine and the hydrogen combines with the iodine to form the respective halide. That means hydrogen bromide and also hydrogen iodide. Hydrogen combines with the bromine to form hydrogen bromide. Hydrogen combines with the iodine to form hydrogen iodide. Again, this hydrogen bromide undergoes decomposition to form hydrogen and also bromine. And hydrogen iodide also decomposition to form hydrogen plus iodine. These are the reversible reaction. Which are the reversible reaction? Hydrogen combines with the bromine and hydrogen combines with the iodine also reversible reaction. Okay. Next about the decomposition reaction. For the decomposition reaction, here we are taking concentrated sulfuric acid. Okay, concentrated sulfuric acid displaces HCl from ionic chloride. Clear? Concentrated sulfuric acid displaces hydrochloric acid from ionic chloride. Hydrogen fluoride can be prepared from ionic fluoride. Hydrogen fluoride, that is HCl, hydrogen fluoride, that is HCl, can be prepared from ionic fluoride. And also HBr, that is hydrogen bromide and hydrogen iodide can be oxidized by concentrated sulfuric acid. These are the three displacement reactions. The first displacement reaction is concentrated sulfuric acid displaces hydrochloric acid from ionic chloride. Concentrated sulfuric acid displaces hydrochloric acid from ionic chloride. That's the first one. Concentrated sulfuric acid displaces hydrochloric acid from ionic chloride. This is the first equation. The second equation is hydrogen fluoride can be prepared from ionic fluoride. Hydrogen fluoride can be prepared from ionic fluoride. The third one is HBr, that is hydrogen bromide and hydrogen iodide is oxidized by concentrated sulfuric acid. These are the three important displacement reactions. Next, about the hydrolysis of phosphorus trihalide. Hydrolysis of phosphorus trihalide. Here, in phosphorus trihalide, add a drop of water to form hydrogen halide. In phosphorus trihalide, we are adding a drop of water to form hydrogen halide. To a red phosphorus, add bromine into the dropwise, we get HBr. Okay, to the red phosphorus, we are saying phosphorus. Okay, in red phosphorus, we are adding a bromine. In dropwise bromine, we have two bromine molecules. We are adding dropwise adding bromine, we get HBr. That is, we are saying hydrogen bromide. Okay, next about to a mixture of red phosphorus and iodine is added to water in dropwise, we get hydrogen iodide. Red phosphorus, we are adding some iodine in dropwise. Iodine add water in dropwise, we get hydrogen iodide. Okay, and we have a small equation. Let us please all of you take a note. We can write the equation. The preparation about the mixture of red phosphorus and iodine. Red phosphorus and iodine. We are adding a water in dropwise. So what's the product? Then phosphorus, we are writing the symbol of phosphorus means P. Am I right? Phosphorus reacts with one of the halogen, that is X2. Okay. Phosphorus with halogen to form X2. Okay. We get phosphorus halide. We get what? Phosphorus halide. We are saying phosphorus trihalide. How can we balance the equation? Phosphorus can be written as 2P. Okay. 2 phosphorus. Now the equation. What about the halogen X3? Now the equation is balanced. Am I right? This is the first equation. Next one. Here, this phosphorus halide reacts with water. This phosphorus halide, that is PX3, phosphorus halide will react with water. So, what are the possibility product here? H3PO3. What's in the H3PO3? The many times we learned that H3PO3. What is that on H3PO3? Phosphorus acid. What's the name of this compound? Phosphorus acid, H3PO3. And also, hydrogen combines with the halogen. We get HX. We get HX. So, how can we balance the equation? Here balancing, here having, make it 3 hydrogen. Okay, make it 3 hydrogen. So, we get 3 hydrogen. 3 plus 3, 6. Okay. X also okay. Then about phosphorus P oxygen also 3. Now the equation is balanced. Am I right? The next one is from covalent hydride. Halogens are reduced to hydrogen halide by hydrogen sulfide. That we are taking hydrogen sulfide. The formula for hydrogen sulfide is H2S. Am I right? H2S. Here the hydrogen sulfide is reduced. Am I right? Reduced to halogen. Reduced to halogen. We are taking X2. X moles X2. What is X2? Maybe fluorine, chlorine, bromine, iodine. Okay. Here, which are the possibilities here? This hydrogen combines with maybe halogen. We get HX, and also we get sulfur. Here, halogen sulfide. Here, sulfur is reduced to as a sulfur, and hydrogen combines with halogen to form hydrogen halide. So, how can we balance the equation? 2 hydrogen make 2 here. Now the equation is balanced. Next, about what are the general properties of hydrogen halide? Here we are saying bond dissociation energy. Bond dissociation energy of hydrogen halide. Bond dissociation energy. That is, some of the molecules possess some certain energy. That is a bond dissociation energy here. Dissociation means we are separating. The one of the compound we are saying, for example, hydrogen fluoride. Here hydrogen fluoride, hydrogen Br, hydrogen chloride, HCl, HBr, HI. These are the respective halogen with halogen. Okay, that is hydrogen combines to fluorine. That is first one. Hydrogen combines to chlorine. The second one. Hydrogen combines to bromine. The third one. Hydrogen combines to iodine. This is the fourth one. Here have you what is the bond dissociation energy of hydrogen fluoride? What is the bond dissociation energy of hydrogen fluoride? That is about the plus 562. This is the bond dissociation energy. Value about 562 for hydrogen fluoride. Next one is plus 431 is for hydrogen chloride. Okay. Next about 366 for hydrogen bromide. Okay. 366 for hydrogen bromide. Next one is 390. 298 for hydrogen iodide. 298 for hydrogen iodide. Okay. What is about the hydrogen iodide? 298. Next about percentage of ionic character of hydrogen fluoride. Percentage of ionic character of hydrogen fluoride is about 43%. First one. The second one is that is HCl is about 17%. Next third one HBr 13%. Ionic character is about 13%. Hydrogen iodide is about 7%. What is the ionic character? Ionic character of hydrogen fluoride is 43%. HCl 17%. HBr 13%. And also hydrogen iodide is 7%. Okay. Next about we are giving the assignment work. Okay, assignment work. Listen all of you. I think that we are ending the lesson. So the previous I think that the second unit, some of the few students are asking some doubt about. I already sent that video to that particular person. That is the I think the page number. Assignment page number 55. That's a book bag question. Question number 12. Complete the following reaction. Complete the following reaction. It's a page number 55, question number 12. Okay, complete the following reaction. I think that A2J. Okay, this question number again. So all of you should write the equation. Okay, that you have some equation. All of you should write. And also, if you have any doubt to balancing this equation or anyhow, if you have any doubt, please call me. And also, again, I am giving the page number 65. Here we are seeing oxides of nitrogen. Next about page number 80. So page number 72. Oxides of phosphorus. Page number 80. Oxides of sulfur. Page number 80 and 81. Okay. Here, those who are interested, this is not a compulsory. Those who are interested to draw the structure of oxides of nitrogen, oxides of phosphorus, oxides of sulfur. Here, oxides of nitrogen is page number 65. Oxides of phosphorus is page number 72. And oxides of sulfur, page number 80 and 81. Those who are interested, you can draw the structures. Okay. I am not telling that all the structure is not. At least you should be draw any one or two is enough. Okay. I hope that you maybe understand what is the today assignment, and also this is the compulsory form. All of you should be right. If you have any doubt, please call me. Okay. Thank you all of you. Thank you. Have a nice day.